Hi folks, we're going to take a look at number 3 from page 578. So here in both of these are asking us to find the derivative at a particular x value, or in this case here t value. So first thing we have to do is find the actual derivative. So let's start with a here. Now there's a couple of ways you can find the derivative of this function. One thing you can do is use the chain rule, make this whole thing your u, and then after that, when you're finding the derivative u, use the quotient rule. But I'm going to try to save myself a bit of time here because I notice that I have the logarithm of a quotient, and so we know that a logarithm of a quotient can be written as this the difference of the two logarithms. So I'm going to rewrite this as log base 2 of t plus 1 minus log base 2 of 2t plus 7. Okay, and then what I have is I have a much easier derivative to find because I don't actually have to use the quotient rule. Okay, so let's find the derivative of this here. So f prime at t is going to be equal to the derivative of the first. We're going to have to use the chain rule here. So this will be our u. So derivative of log base 2 of u is 1 over u ln 2. So 1 over u, so 1 over t plus 1 times ln of the base, which is 2. Okay, and times the derivative of u with respect to t, in this case here, is just equal to 1. Because that's 0 and the derivative of t is just 1. Okay, so not much to do there. So here, same thing, we're going to have to use the chain rule again. We'll call this v. So derivative of log base 2 of v is 1 over v ln 2. So 1 over 2t plus 7 times ln 2. Okay, times the derivative of v with respect to t, and that would be equal to 2. So I can just put a 2 there in the numerator. Okay. So now I could simplify this here, or since I just have to determine the derivative at one point, in this case here at t equals 3, I'll just stick this in and do my simplifying afterwards. So what do we have? We have 1 over, so 3 plus 1 is 4, so 4 ln 2 minus 2 over 2 times 3 is 6, plus 7 is 13, so 13 times ln 2. And so we'll work with a common denominator. So the ln 2 is in each of the denominators already. So we'll need a 13 up here. So 13 minus 2 times 4 is 8 up there. So here we've got 4 times 13 is 40 plus 12 is 52 ln 2. Okay, so in the end we have 5 over 52 ln 2. And you can't really simplify any further from that. Okay. So again, step number 1 was to find the derivative and then input the particular t value. In this case here, I use the fact that the logarithm of a quotient is the difference of the logarithms to simplify my life. But of course, I would have gotten the same answer had I used the chain rule and then as part of that used the quotient rule. Okay, let's move on to b here. So there's no real simplification I can think of doing here, so we'll just find the derivative directly. So h prime at t. So here we have composite functions, so we'll take the derivative of the outside function first, so this will be my u. So derivative of log base 3 of u is just 1 over u ln 3, so 1 over log base 2 of t times ln 3. Okay, and multiply that by the derivative of u with respect to t, and that's pretty straightforward. It's just 1 over t ln 2, because that's the base here. Okay, and so now we have to determine h prime at 8, so we'll just input 8 here. So we have 1 over log base 2 of 8 times ln 3, okay, times 1 over 8 times ln 2. Okay. So first thing I notice here is log base 2 of 8 is just equal to 3, because 2 exponent 3 is equal to 8. So 3 times 8, so we've got 24, and then we've got ln 2, ln 3. Okay, and of course that's all in the denominator. Okay, because I'm just multiplying these two fractions. So again, just to recap, find the derivative. In this case here, we need to just use a chain rule, and then input 8, and then simplify as much as you can. Okay, that's it for these.